about problems on vibrating string. Why are we going to talk about vibrating string? Because vibrating string is the area where we have the vibrations which happen in a waveform. So since I am talking about boundary value problems in waveform structure, I am going to discuss a scenario where we are going to talk about various types of problems on vibrating string with zero initial velocity. You very well know velocity. What is velocity? Velocity is nothing but rate of change of displacement is called velocity. What is acceleration? Rate of change of velocity is called acceleration. Okay. So displacement is nothing but, what is displacement? The movement of an object with respect to some time is displacement. So the rate of change of displacement is called velocity. So there can be two scenarios in an experiment. One is you might be starting that experiment with an velocity, or you can start an experiment without velocity. Okay, so in our discussion we will be talking about two things. One is without velocity and one is with velocity. In two scenarios we will be talking. Okay, so in this first I am going to discuss something on problems on vibrating string with zero initial velocity. Okay, what is the wait and see, just wait and see. A tightly stretched string. So the string is there, it's fine. The string is there, it's tied at two ends, and a tightly stretched string with a fixed end points x equal to 0, x equal to L. There is initially in the position, maybe I am telling that there is initially before starting the experiment, it is in a kind of position. Maybe I have pulled up, so it is I have pulled the string to the point C or D something. So this is the initial position. Let us assume. Now, what I say, it is said vibrating by giving to each of its points a velocity. Suppose I told you there are two scenarios. One is you can start the experiment with velocity or without velocity. Suppose what I do now. So I have put the string to a particular distance and I am leaving that string. I am just leaving that string. What happens now? What happens now? So that string will start vibrating. The string will start vibrating. So in order to understand, so find y of x comma t. That's what I told you. This y of x comma t is nothing but we are going to talk about the displacement. We are going to talk about the displacement. So this y is called the displacement function. So the y is called the displacement function with two parameters. One is x with respect to x. We can even have it as variables, two independent variables. One is with respect to x and with respect to t. T is nothing but time. So how to work out, how to find the solution? For this we need some conditions. So as I told, boundary value problems we need certain conditions here. You can see there are conditions like this. The first two are boundary conditions here. So what is here? Y of x comma 0 comma t equal to 0. Y of what is it? Y of L comma t equal to 0. Why it is 0? Because the reason is in the endpoints there is no displacement. In the endpoint there is no displacement. So that is why the first two conditions are 0. What is the next? Y of x comma 0. Y of x comma 0. So y of x comma 0 is equal to some function f. The reason here is now we are not talking about x but we are talking about time. So when you are going to start an experiment at that present time, the time is taken as 0. Now I am going to start the experiment. So t equal to 0. Remember it? T equal to 0 is the starting time. So when you start the experiment, so y of x comma 0 equal to some function between the distance 0 to L. Then the last one is dou. What is dou y by dou t? This we are talking about. What is dou y by dou t? This is nothing but velocity. So the fourth point is dou y by dou t is velocity. Maybe there can be a scenario with velocity or without velocity. But you need these four conditions to work out this problem. If you are given a question in the exam and if you are told to talk about vibration of strings, that is wave related problem, then you can be very clear. You should memorize these four conditions where the first two are standard conditions. And the third and fourth, the f of x, g of x will be according to the given problem. Okay. So in order to solve this, these conditions, we have various stages of solving this. We have a set of methodology, terms and conditions are there. We will go one by one. So once if we are going to solve this, we are using, see, there is a statement, see, the solution is given by y of x comma t equal to in terms of sine and cos. That is, in order to solve this problem, we are using a standard solution, general standard solution. That is nothing but the first equation 1. So that is the standard solution formula. And the solution from there, we will solve the problem. Thank you.